All
Yep,
good.
awesome. So, hey folks, I'm Naveen, and today I'll be talking to you about how Hasura uses complex indexes for event triggers. And I see Brandon is also on the call, so if I do make a mistake, please do correct me. And let's go. So, yeah. So, before we jump into it, let me try to give you a very brief intro of what event triggers are. So, Hasura events basically are nothing but uh, it's a mechanism where we use to reliably capture events from any tables. And once we get that event, once we get that payload, we just transfer it to any webhook for whatever business logic a user might want to do. So the one thing that you might have to remember for the entire talk is that the events that we capture is stored in something called as event log table. And Hasura keeps fetching those, keeps polling that event log table to fetch the top 100 undelivered event. So this looks pretty simple, but what's the actual problem here? The problem here is that the event log table, that's the Hasura events, the size of that may keep on increasing. And once it keeps on increasing, the question comes, how do we efficiently fetch the top 100 undelivered events from this table, right? So one might ask, why can't we just use a sequential scan? But the problem with the sequential scan is, say, I have somewhere around 10 million rows, so 1 million rows, and I would like to fetch 100 events. The time it would take me would be like 2 seconds, and this is not acceptable, right? So we thought, okay, let's go ahead and add some simple indexes and see how it might improve the performance of fetching the events. So we thought the basic, like the simplest index would be like, since we want to fetch only those events which have not been delivered and had not been had not been fetched by any other instance. So let's just create the single column indexes on log delivered and created that column. But this didn't help as much, as you can see that even the execution time still remains the same. So after a lot of research, we ended up with the actual final index that you see on the screen. So the logic here was that like we first would like to use our static filter to filter out all those events which have not been delivered or have not errored or not have been archived. And once we get that, we want to sort them on the basis of those events which have not yet been delivered at all. That's why you see that log nulls first. Basically, that means events which have not been logged, and then the events which have not been set for a next retry, and so on and so forth. So the question comes, why did the last index didn't work? Just because we add an index doesn't mean that it's going to guarantee faster execution times, right? So when we dug deeper, we just found out that for this previous index, what Postgres did was the Postgres query planner choose only the created at column as the index, and this ended up degrading the entire index search into basically a linear search. That means we kept on we kept on searching the entire row one by one and started filtering out events. That means this is bad because we are still going through all the processed events. That means we're double checking all the events in the table. So this did not work out. And secondly, why did this index work is because what we wanted was we wanted events that were not delivered, and that means the nulls value. When event is not delivered, the value of the delivered column is null. Okay, so when the value of the delivered column is null, by default in a normal Postgres index, all the null values are pushed to the bottom. That means you still have to go through all the processed event to reach to the events that have not been delivered. And this is not what we actually want. We want it to be the reverse. That is, all the log columns, all the events that have not been delivered to be at the top. So when you do this nulls first, the entire table gets sorted to the reverse. And that means you are not, this basically fastens up the entire process because you are first directly hitting the events which have not been delivered. So this was the this was the reason that the change we made in the index works. The main point of this, okay, let's see the thing that happened. Like when we use this proper index for a row with some 20 million 20 million rows, we can see that the execution time was only 3 milliseconds. That's like a huge improvement from like 2000 milliseconds to 3 milliseconds. And again, the benefit of this was that even though the event log table grows, the execution style still the execution time still remains constant. That, as you can see here, like let's say we just take 10K rows, the execution time is still 3 milliseconds. And even let's take a 5 million rows, the execution time is still 3 seconds. And even though we reach some 20 million rows, the execution time is still 3.189 milliseconds. So this is how Hasura uses this complex indexes to actually fasten up the event delivery process. And yeah, that's it.